Hey guys, it's Andrew, and I'm doing a video over double-digit multiplication. In this video, we'll talk a little bit about estimation, and we will talk a little bit about the standard algorithm and a little about alternative algorithms. Uh, at the very beginning here, I have it that I've got my information from k5learning.com, and what that means is the problem that I chose came from k5learning.com. K5 Learning has a variety of worksheets that you can download. I think most of it's for free, at least the stuff that I was downloading was free. And they go all the way up to 6th grade, and I'm not sure if it's just for math. Like, just really, I stumbled upon it. So I want to give credit to the website, and if you have time, go ahead and check it out. Uh, the problem I chose, well, I'm writing it down as we speak. There are 37 baskets. Each basket has 17 apples in it. How many apples are there in all? One good thing about this question is like it's visually appealing. Yeah, I think students can at least imagine it in their heads. If you told them to close their eyes and imagine one basket with 17 apples in it, and then ask them about how many apples they think there would be if there were 37 baskets with 17 apples in it. Uh, Here's the estimation part. For me, I like front end rounding. I like to do it twice. With front end rounding, you're just going to take the leftmost number. And usually it's just one number. Sometimes you can do two. And you can multiply it. And I do the low end first, always. And on the low end, we have 30 times 100, which is, or 30 times 10, which is 300. And then I like to round up afterwards. So 37 becomes 40, and we're going to multiply that by 20. Just to refresh your skills, guys, what is 40 times 20? Does anybody know? 40 times 20? If you guessed 800, go ahead and give yourself a pat on the back. So now we have these two numbers, 300 and 800. And so this gives us a clue about our multiplication problem that we're going to set up later, which is 37 times 17. Our number should fall within this range. So if our number doesn't fall within this range somewhere in the middle of it, then we know that we made a critical error somewhere. The first thing I want to show you guys is the standard algorithm. I went ahead and set up the problem. And in the standard algorithm, we'll take the ones place value and multiply it by the next ones place value. And when we do that, we know that it's going to be 49, and we'll regroup the 4. Here you got to be a little bit careful. You don't want them adding the 4 in with the 3 before they multiply. 30 times 7. But once you're done, you should get 259 for your first part. Next, we'll drop down straight from the tens column and start with 10 times 7. And we don't want to regroup the 4 again. We've done it once, and that's all we need to do. That 37 represents 370, and I'll show you later why. And once we do all the addition that we need to do, we come up with 629. Now, every time I do a math problem, it's always good to get in the habit of double checking yourself. It's not that I don't know it, it's just, you got the calculator there, you might as well double check your answer if you're able to. So the next thing is the alternative algorithm. This one focuses on partial products. and partial products is fairly simple to explain. It's very helpful because it breaks down everything in multiplication into smaller parts. And this really emphasizes the place value. And the first thing that you might notice is that you're not going to put the 4 up top. You're going to drop it down and just keep it 49. Now, whenever you're multiplying the 7 times the 3, you're really saying 30 times 7. And when you do that, you'll get an answer of 210. You'll follow this pattern for the next number, which is 10 times 7. And for that, we will get what? 70, right? Yeah, 70. So can anybody tell me what we're going to do here for our last part? Okay, so 30 times 10 is 300. Now we're going to take all our partial products and we're going to add them all together. We got 9 plus 0 plus 0 plus 0, which equals 9. We have 4 plus 1, which equals 5, plus 7 equals 12. And we'll regroup the 1. We got 100 plus 200 plus 300, which equals 629. We'll go ahead and take our standard algorithm and we'll compare. And I want to point out that when I said this 37 over here on the standard algorithm really means 370. I hope that you guys can see it in the partial products that 300 plus 70 is 370. And that's why we wrote it kind of shorthand in the standard algorithm. And I want to point this out too. You could start off by standard algorithm, teaching students standard algorithm, but you might encounter problems like I've stated before, like the regrouping of the 4 and the 3 before you multiply by the 7, and the same mistake could be made with the 1 and the 3 and the 4. You know, somebody might be out there who adds in the 4 to the 3 in the tens column to make it 7 and then multiply by 1, and that would change your answer a whole lot. So starting with partial products might be better until they can think more abstractly about it. So as you can see, like I said, our answers are the same. So we're going to go ahead and circle our answers. And we're going to come back to our first page and we're going to look at our estimations. As you can see, our number should be within 300 and 800. That's the realm we're working in. If we didn't get an answer in between those two numbers, then we need to think about it a little bit harder. So is 629 in the range? And if you guessed yes, give yourself another pat on the back. This will conclude my video. Thanks for watching, and if you have any questions, don't hesitate to ask.